So what is the equation of continuity? Let me state first, and then I will go into the details of it, right? So the equation of continuity says for a incompressible. So we are putting some conditions because to make this case simple, we are dealing with some conditions, right? What if it is not incompressible? We will discuss that later. But right now we are putting some conditions around. That is for an incompressible, non-viscous, streamlined flow. So there are three conditions around it. I'll explain each of the condition immediately after the statement, but let me first complete the statement. Whatever it says is for an incompressible, non-viscous, streamlined flow, the equation of continuity says the mass of the fluid that enters per second, or we can say that's the rate of the mass of the fluid that enters per second, whatever that enters into a particular space, particular system from a fluid, is the mass that comes out of the system. That means whatever the mass of the fluid that enters into a system comes out of the system means to simply say that system is not going to eat out any of the mass. Whatever it's just like a conservation of mass. Whatever the mass enters, it's the mass that comes out. So mass of the fluid per second is constant, or the mass that comes in is the mass that goes out per second is the equation of continuity. So before going into further that what is the meaning of that, let me explain what is the meaning of these things like incompressible. So we said a statement like incompressible. What do you mean by incompressible is it's not compressible. That means its volume is constant. Once if you say its volume is constant, its mass is anyway constant because mass is always conserved. Density, you know the definition of a density as mass by volume. As the fluid is incompressible, volume is constant and mass is already constant, and hence the density rho or d is constant. So when somebody say it's incompressible, he is telling you that its density is a constant. It's not variable. That's one thing. The next thing that's being said about here is it's non-viscous. You know, fluid moves like set of layers, and there is an opposition among the layers internally that each layer opposes the motion of the other. That's like a friction, right? But we are not talking about that case right now. We will go into the subject and talk about it. There is, in fact, a separate topic called viscosity. We will handle that later. But right now, we are assuming that there is no viscosity, non-viscous, no internal opposition. Just to make the case little simpler, we are just assuming. The third case is it's a streamlined flow, organized flow, regular flow, laminar flow. There are so many names. All these names simply tells you one thing that say, let me explain what's the meaning of that. This is the fluid flow. This is a point in the system. Fluids are coming like this. There are so many fluid particles crossing this particular point. All the fluid particles crossing this point moves or crosses that particular point with a constant velocity. Be careful. I'm not saying that velocity is constant at all parts of the fluid, at all points of the fluid. No, I'm not saying that. What I'm simply saying is at a given point, all the particles, when this first particle crosses with velocity v. The second particle crosses with the same velocity. Third particle crosses with the same velocity at that particular point. Then that's called as a streamlined flow. If otherwise it's called something like a regular flow or a non-streamlined flow, what happens then? We will deal it later. So right now we have kept three conditions. It's incompressible, volume is constant, and hence density is constant. Generally, people refer with rho here. Non-viscous, no viscosity is taken into consideration. In this case, we are treating it like a simple case of no opposition, ideally. And a streamlined flow, all particles crossing a particular point crosses with the same velocity in a given fluid flow. In that case, our equation of continuity says mass of the fluid per second is constant. That means mass of the fluid that enters is the mass of the fluid that exits, that comes out in a given point. That means to say the rate of the mass, that means whenever you say rate, it means to say per time, is constant. That's the meaning of the equation of continuity. What's the meaning of that? If you try to understand it even further, mass can be written like, as you know, the definition of a density as mass by volume, and hence mass can be written like density into volume. So, rho into dV. Rho is density, dV is the change in the volume, by dt is constant. If you further simplify this, rho, change in the volume can be written like area multiplied by change in the length by time is constant. Now you see change in the length by change in the time, rate of change in the length or rate of change in the displacement, that's nothing but velocity. That means rho a v is constant. As I already said, it's an incompressible fluid, therefore density is already constant. So that implies area into velocity can be written like constant by rho. Constant by another constant is also a different constant, but still that's a constant. So the equation of continuity simply tells you area of cross section of the fluid multiplied by velocity of the fluid is always constant. So that's a very big lesson actually, very simple and important lesson. We do have seen this at so many times in our real life. Let me explain with a simple example. Say there is a pipe with a bigger opening. At the other end, the pipe is having a smaller opening. You call this area as A1, you call this as area as A2. It's very clear A1 is greater than A2. This is smaller, this is bigger. Here, if the fluid enters with a velocity V1, here the fluid comes out with a velocity V2. You can guess A1 V1 equal to A2 V2. As A1 is greater than A2, it's obvious that V2 will be greater than V1. That means the fluid enters with a lighter velocity, smaller velocity, comes out with a larger velocity. This we can notice. You close the tap and the water is coming out in your bathroom. If you close half the tap, you can very clearly notice water gushing out with a higher speed. That is simply because it is explaining the equation of continuity, right? So equation of continuity gives a very important understanding of fluids and ideal conditions. Of course, there are conditions, but still it's a very important understanding to say that area of the fluid multiplied by the velocity of the fluid at a given point is always constant. So the very meaning of that is the mass that enters is the mass that exits. That's it. We'll continue this discussion and solve some problems on that as we go ahead in the lesson, right? Thank you. Thanks for watching.